All right, so let's just say like, you're bored one day, and so like most teenagers, you just decide to add up all the whole numbers up. You're adding 1, 2, 3, 4, 5, 6, 7, 8. You're just adding all them up and you're trying to figure out what number these will equal when you add all these numbers up. And forget about, infinity, pretend, this is back before you even know what infinity was. You're like, I wonder what number this is. So then let's just set this equal to a. Let's have a represent the sum of, all the whole numbers. So then what we can do is we can actually group these into groups of 9. So if you notice 2 plus 3 plus 4, this will give you a 9 in there. And then if you go 5 plus 6 plus 7, that'll give you a plus 18. And you do the next 3, 8, 9, 10, and yep, 27. And even the next 3, 23, 36. So you notice this pattern. You notice that after the 1, you can add up multiples of 9. And then working this out, well, let me now factor out. You factor out a 9 from there. So you can factor out a 9 from this group here. So you have 9 times 1 plus 2 plus 3 plus 4 plus da da da. And what then happens is that this 1 plus 2 plus 3 plus 4, that's what this whole original value of a we had was. So we can actually now write a is equal to 1 plus 9 times a. And so then solving for a, taking away 9a from both sides, you'll get negative 8a equals 1. Dividing both sides by negative 8. And then you'll get that a is equal to negative 1/8. But we put a equal to this whole sum at 1 plus 2 plus 3 plus 4 plus 5. So then you have that negative 1/8 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6, blah, 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 all the whole numbers. So now, like, so like, what the heck is going on here? Like, we know this can't make any sense. Otherwise, we got a big issue. So let's think for a minute. Look at what we did that was not mathematically sound, so to speak. And it's not like we added incorrectly or something like that. But we essentially assumed here and then here that we can use the distributive property for a group that is infinitely large. We assume that we can carry distribution across this group here. In other words, you're typically taught in algebra, if you remember this, that you have like, x times, a plus b plus c is equal to x times a plus x times b plus x times c, because you distribute the x to each term on the inside of the parentheses. But we're not told that you can apply this to an infinitely large group. Like if this group went infinitely in there, would that then equal x times a plus x times b plus x times C plus da da da. So you keep on doing that over infinitely. And the answer really is that we can't really prove that this isn't true. But the thing about math is that it like every area of math, meaning like algebra, geometry, calculus, you have to have some set of rules that you're going to begin with, like, or we would call them axioms in math. And this is something that if you're in high school and you're first learning, your the math algebra maybe during your freshman year, and sometimes you'll see like these conditions, like for real numbers, you'll see like a fancy looking R like that, or like recently I was going over something like a reflexive property where AB line segment AB is congruent to line segment BA, and like students will be like, what's the point of this? Like, why do we have to do things like that? Well, here's an example why we have to make sure we define axioms or things that seem like they're common sense, because if you don't, then things like this can happen, and we have to live with it. Like if we don't define that we can't distribute infinitely, then whatever result we get, we have to just accept, meaning that we have to accept that -1/8 is equal to 1 plus 2 plus 3 plus 4 plus 5, which we know is not true. So we can't say that this distributive property carries over infinitely. So, and there's more to it than that. You have to really go in deep into like discrete mathematics to really learn about like set theory and stuff like that. But that's kind of just the general idea. It's important that you always understand that that math, all areas of math start with a set of axioms. And it's very interesting. Problems like this got me very fascinated in math when I became a math major in college. So there you go. I hope you find that interesting. Let me know what you think.